What is probability? What is the probability that the sky will collapse one day? What is the probability of devourers of the universe? What is probability of God? I'm not going to walk you through the basics of coin flip odds. What's the chance of getting heads or tails, or of getting tails on two coins at once, or twice in a row, or 57 times in a row? I figure you already know all that.
Who loses 57 coin tosses in a row? Heads, she wins. Tails, I lose.
Today, I'm more interested in the deeper meaning of probability, the philosophical side of it, if you will. So let's actually try to get our heads around what probability is in the very essence of this concept. People often confuse probability with prediction. Sometimes they even treat it like some kind of guaranteed forecast. For example, if an event has 80 or 90 or even 99% probability, does that mean it's going to happen? And because we mix up probability with certainty, we tend to feel like, yeah, this is going to happen, probably. In fact, probability does not work as any kind of guarantee about the future at all. It does not promise any specific immediate outcome. It says nothing about it at all. Originally, probability theory is tied to mathematical statistics. It grew out of watching events repeat over time. And probability theory isn't some separate fortune-telling magic. It's an attempt to describe what we've already observed in the past. When we notice that the outcomes of certain events are distributed by how often they show up, we start thinking, if the event keeps repeating, its results will fall into certain categories, and with enough repetitions, those results start to settle into a pretty stable pattern. In other words, probability is an attempt to describe the outcomes of events that happen over and over. If we roll a die once, we might get 1, 2, 3, 4, 5, or 6. It feels completely random. If we roll it 10 times, we will probably see a mix of results, but it's still chaotic. And roll it 100 times and we start seeing a pattern. Each face comes up about equally often. That about gets more and more accurate the more rolls we analyze, but only if the die is fair, symmetrical, not weighted, and no shifted center of gravity, none of that physical trickery. Roll it 100,000 times, and the distribution smooths out even more. Each face shows up almost exactly as often as the others. At a million rolls, even closer to perfect. And this is where an idea comes in. If we imagine an infinite number of rolls, which is purely a mathematical abstraction, not something we could actually do, but math can do that because it has tools to handle infinity, then at infinity we would get absolutely equal counts of 1s, 2s, 3s, 4s, 5s, and 6s. But since we cannot never actually run that experiment, we can't flat out say that's what happens. We just say the number of times each face comes up approaches the ideal value, in this case 1/6. The probability of rolling a 3 is 1/6, and the probability of not rolling a 3 is 5/6. That's over 80%. Pretty high probability. Does that mean that on the next roll we won't get a 3? Not at all. All it means is that if we roll the die a whole bunch of times, about 5 out of 6 rolls won't be a 3. That about depends on how many trials we're looking at. It's a margin of error that shrinks as the number of trials goes up. At infinity, that margin disappears. And here is the crucial bit. Probability is not about a single event at all. It's about how things behave when they are repeated over and over. It looks at past frequencies, and talks about the future, but only in one sense. If you repeat this enough times, you will get a certain distribution of results with some margin of error. And if you repeat it infinitely, you will get it with zero error. That's it. But it says nothing, I repeat, nothing about what's going to happen on the very specific trial. Still, the probability of not rolling a 3 isn't that high, only about 80%. Maybe that's why a 3 still shows up sometimes? No, of course not. Let's look at a more extreme case, the lottery. Say there is a drawing with 10 million tickets, all sold, and the rules say exactly one ticket wins. The probability of winning with one ticket is 1 in 10 million, that is 0.00001%. That's absurdly small. Even buying 100 tickets bumps it up by a factor of 100, but it's still barely a blip, 0.001%. Meanwhile, the chance of not winning with the ticket is 99.99999%, purer than gold in Fort Knox. Does that mean a single ticket buyer never wins? No, they do. Does it mean people who buy one ticket never win? No, they sometimes do. Does buying a lottery ticket guarantee anything? Absolutely nothing, except that you paid the cost of the ticket. What probability would actually guarantee a win? 90%? 95%? 99%? No, only 100%. In other words, only buying all 10 million tickets at $1 each guarantees you that $1 million prize.
Savvy?
We could further exaggerate the magnitude of probabilities, keep pushing these probabilities to even wider extremes. Cosmic scale stuff, for example, like baryon asymmetry, the formation of a habitable planet, or the origin of life itself, if probability was involved in all those events at all. Just to drive the point home, probability offers zero guarantees about the next individual event. It does not work that way. Probability deals with sets of events, and the bigger the set, the more precise it gets. And that's where a really strange thought creeps in. What if we asked, what's the probability that today the entire atmosphere will collapse down to Earth's surface, then re-expand and return to normal? That can't happen. But we say can't happen not because we've logically proven it impossible, but because we've never observed it, and it doesn't follow from any physical model we know. But what if there were some incredibly rare, yet still possible, convergence of astronomical factors that could produce exactly that? We've never seen it. We've never predicted it based on our theories or knowledge. So within our models, the probability of such an event is effectively zero. It seems like utter nonsense. Even a zero probability within a model is not the same as logically impossible.
It's not possible. Not probable.
It just means the event isn't in our known set of outcomes and hasn't shown up in our experience. Someone might object that this is a made-up straw man example. Fine, let's use a real one from history. Before Einstein's theory of relativity, before John Mitchell in 1784, if you would ask not just an average person but even a scientist, could there be regions in space that pull in all surrounding matter with no escape? Places that gradually swallow everything around them, devourers of the universe? You should have called an exorcist. Or people would dismiss the very idea outright. They would assign it a probability of zero, but relativity opened up the theoretical possibility of black holes. Karl Schwarzschild worked out the math, and yet even Einstein himself, who had just formulated relativity, initially rejected the idea. He called it nonsense and said it could not exist. However, it turned out that black holes do exist. So until something actually happens, or until we learn that it can happen, our probability estimate for it is zero, with a margin of error, of course. The idea of black holes seemed impossible for a long time, although it later became part of observational reality and established physics. So before we know something or observe it, we often just don't know how to fit it into our models. And in this sense, the probability can be zero, not because it's truly impossible, but because it's absent from our model. But once it enters the observable world or becomes theoretically described, it receives a probabilistic treatment. It's important to separate this. It's not that the event gains probability as a physical property. It does not have that kind of property. The world does not change. What changes is our picture of the world. Probability is our way of describing the world, but it's not part of the event's inherent nature. So back to the question, what's the probability that the sky collapses today and then reopens? Right now, our answer is 0%. But if we ever derive that possibility from theoretical knowledge, or if it actually happens someday, we would assign some probability to it, assuming anyone's left to do the math. Come to think of it, is that part of why modern science treats the probability of prior civilizations as basically zero? And here is the main takeaway. Probability is neither a guarantee nor a prediction about any one specific event. It either happens or it doesn't. And on top of that, sometimes events we once gave zero probability to actually occur, but that doesn't mean anything is possible without limits. Or does it? Just kidding. Most likely.
I think he's telling the truth.
If he were telling the truth, he wouldn't have told us.
Unless, of course, he knew you wouldn't believe the truth, even if he told it to you.
No matter what the probability of an event is, it is either going to happen or it's not, and probability has zero effect on that outcome. It only records how the frequencies of different outcomes would distribute if you repeat the event enough times. Again, despite whatever the probability is, the result of this specific next event is, in reality, completely unknown to us. So when someone argues that something is impossible and uses probability to back it up, they are being a little dishonest. Either they are using the theory as armor, or they are fundamentally misunderstanding what probability actually is. Our entire existence is an absurdly improbable event, from the lucky chaotic asymmetry after the singularity to the exact fine-tuning of all physical constants, the perfect distance from the sun, and on, down to the odds of life arising at all. Multiply all those near zero probabilities together, and you get something so staggeringly tiny that you would have a better chance of meeting a dinosaur. And yet it moves. And if we go all the way down to the deepest level we know, the level of elementary particles, where everything is governed by probability distributions, we realize that probability leaves us with more questions than answers. A particle exists in all possible states at once, and in none of them specifically. In other words, probability hasn't kicked in yet. The particle is in a wave state, a wave function that contains all possible probabilities for all possible states, but none of those states have yet been selected. Then, when an observation occurs, one of those states is realized. And once again, it happens regardless of the probability of the state. What's more, mathematically speaking, all possibilities are realized, which messes with physicists' heads because then you have to talk about multiverses, infinite branching universes, but that's a whole other topic. I cover that in other videos, not today. By the way, experiments on whether an observer can influence quantum outcomes have been done. They are unstable and hard to reproduce, so science does not yet treat them as solid evidence. Hypothetically, we can imagine that the observer's intention or internal state could steer which probability gets realized, or better say, which branch of realized probability observer selects. But that's unproven. So far, maybe forever. In the end, we have no reason to think that the state a particle picks when observed depends on how probable that state is, no matter how high that probability is, because both the most likely and the least likely states get realized. Yes, statistically speaking, the more probable outcomes show up more often, and the less probable ones show up less, if you run the experiment many times. But again, really let this sink in. Probability tells us nothing about what the actual outcome will be, or which specific result will occur in the particular event we care about. The probabilities of different outcomes do not in any way guarantee or even inform us about what will happen this time. At best, they tell us what outcomes are possible and how frequent they would show up if we run the experiment an infinite number of times, or at least a whole lot of times. That's it. So do not treat probability as a prediction or a guarantee. It's an analytical summary of historically observed events, or a mathematical approximation of how results will distribute over a large number of future repetitions. And it says nothing about the actual present moment. So does that mean that even things that can't happen might still be possible? And what is the probability of God?
Savvy?